Industrial controls. What do they do? So going to go back to mid-80s. I had been working in the oil field on non-destructive test equipment, doing design engineering and maintenance, and oil field collapsed, not a business. Long story there. Worked with spectrometers for a while in there. Fascinating job. Other videos, the science in its spectrometer, optical emission spectrometer, is pretty impressive. So, get a job at a chemical plant down in the Houston Ship Channel. Brand new chemical plant, still being built. When they hired me, it was in startup and commissioning mode. And the plant had two facilities. One manufactured phthalic anhydride, a plasticizer, and the second manufactured 2-ethylhexanol, which is basically an oil used specifically as 100% internal use by the steel company that was a partner in this joint venture chemical operation. So the 2-ethylhexanol, so it was an internal use product for the steel company. You see it, it's a metal coatings they use to finish or protect steel after it's been processed. So it's almost like a diesel fuel kind of feel to it. But the plastic was plastic. The phthalic anhydride was plastic. Now this plant was engineered by a German company. So it was all German engineers on this side. The 2-ethylhexanol plant was designed by a British company. These are big companies, engineering houses, though. So haven't been through them very much, but I've mentioned them before. So there's a cultural difference between two of these sides. Now, so industrial controls. To me, I came in with deep electronics background and heavy instrument background, but the control systems wasn't my specialty, but I knew computers. So got introduced to a Rexnord Automation EMC D2 control system and became pretty much an expert in that, but didn't work on the program side very much other than operator interfaces. The plant was designed based upon other existing facilities. This was a world-class facility, but what they had done is automated every bit of the process. So this plant in another country, half the size of this one, half the production capability, would have almost 300 operators a shift because of the number of valves that you have to turn out there in the field and the process and what it takes to run and control these things. So this was the largest industrial application at the time, or one of an automated control system. Over 3,000 digital I/O points, and my instruments were either multiplexers that supplied additional information. So in all, there were thousands of endpoints out there that were either inputs or outputs, valves or meters, or so. Kind of the key here is 300 operators to roughly 8 or 10. 8 or 10 operators, 2 or 3 sitting at consoles, walking everything, everything run. Every bit of the operation of the plant was automated for the most part. Now, warm up and startup times took extra crews, but there was always contractors around. So lots of things contracted because you can't keep a 200-man workforce busy. They come in for a 2-week job and they go. So that's industrial controls and automation. That's one place, one application where it went from what would have been hundreds of jobs overseas or even in America to a dozen jobs to make 1/3 of the world's plastic. That's how small and how big this plant was at the same time. It had a process, it utilized an engineering design process called continuous batch. And I've had debates because people say that doesn't exist, but a continuous running reactor feeding batch condensers is a continuous batch process. And I can go through more of the downstream that shows why that matters and how it's used. So that's industrial controls. My second introduction, this would be my third introduction, I'll skip the one about nuclear controls, was going to work for General Motors, installing conveyor systems and automation information systems and supervisory control systems. And eventually they hired me because that Rexnord thing, that automation, that digital computers, hardware and software, Fortran code, macro, these are the kinds of things you messed with. Even Regis Graphics. Anyone remember Regis Graphics? That's industrial controls. When we came into General Motors and these new design plants, mid 80s again, late 80s, my work cells, my automation cells, our automation cells, I should say, I handled the conveyors and the automation and the supervisory controls. So interlock interfaces to tell a robot when to run, what kind of model to run, or what color it is, or so job tracking, people tracking, time tracking. That is part of industrial controls. Very large systems, very poorly and very well designed at the same time, depending on the intent of the system. So the GM job, our automation work cells replaced, especially the heavy automation cells, replaced operators with electricians watching the robots. So where you might have a 4 or 6 person work cell, we'd have 6, 8, 10 robot work cell, even more, depending on which part of the process, which area of the plant. So we put car bodies together. So you took a body shop down from hundreds of people to dozens of people a shift. Yes, there's operators loading things and there's forklifts driving around. Most of the logistics stuff didn't change. You still got to get all the parts to the line or the parts to the robot. But all the material handling turns into robot work. So once the operator sets a pallet down, or maybe an automatic guided vehicle sets a pallet down and there's no people, it's safer with no people out there on the floor. So there's considerations made all around. And yet you travel down to a Mexico plant or work with South American plants and conference, and the logistics are totally different. The cost of a robot is more than the cost of labor in Mexico. So these same lines were put together by people instead of by robots. Same car, same job, same parts, same truck. So this is global logistics, supply logistics, just-in-time systems. This is people systems, time tracking systems, job tracking systems, job quality systems, all interfaced and layered up into massive decisional data sets. And some of it gets lost in real-time data and is never saved, and other pieces of it get saved off for a lot of reasons. So big industrial controls, that plant you drive by, that huge warehouse you drive by, that you hear about folks working in contract, moving boxes around. Those are mostly automated these days. They're trying to get rid of the people because people get injured, people get in the way. The robots can be done and move things faster, and it takes a lot of integration work to write that everything is custom, everything is a special application in real-time systems and things, considerations that matter. But high-level industrial controls talk what we actually do, but what it means is huge reductions in manpower, increases in safety and health, and less people with paychecks, much higher skilled workforce required to know what the robots are doing, to repair the robots and tune them. But you don't need many because these things have a long life. These robots will sit there and weld and robot for a long time in between maintenance. So there you go, industrial controls. These industrial controls, this global facility that I work with in the chemical plants, in the oil field, tubular goods, all southern states works, but you get to see an oil rig, you get to see where the pipe's used, you get to learn how things are done. Your equipment's dragging around a radioactive source you've got a license for. It's life, what some folks will do.